Welcome back to All This Math. This is Professor Parker. I hope everybody out there is having a good day and we're prepared to do some trigonometry because that's what we're doing in this problem here behind me. I know it might look a little sloppy, a little jumbled together. There's a lot of information up here. Don't let that intimidate you or confuse you. What I'm going to do is I'm going to read the information in the word problem. And the thing is, and this is one of the benefits and why I started this YouTube channel, so that people will be able to have a place to come to get a better understanding of complex math problems, so they can get help with their homework, basically, with complex math problems, such as a problem like this. This is a trigonometry problem, right? But it's not even just like a straightforward trigonometry problem, dealing with SOHCAHTOA straightforward. It's an actual word problem, right? That you have to read, understand, deduce the information. And actually with this one, my recommendation, some teachers might not recommend this, but my recommendation is to draw a diagram, draw a picture so you can visualize what's actually happening, what's actually going on, right? But before you draw the diagram, you got to know how to read the information and pull the necessary and pertinent information out of it that's going to go into your diagram. All right, so check this out. Let's start reading. First bullet point, you're standing 20 feet away from a house. All right, so just imagine that's you. You are standing 20 feet away from a house, right? That's going to go into our drawing. Then you extend your right hand straight out parallel to the ground. Your right hand, you extend it straight out parallel to the ground, right? There's the ground, here's your hand, parallel, right? Meaning the direction of your hand, if you were to draw a line, extend the line from your hand, that line would never intersect the ground, because every point on that line that extends from your hand would be equidistant from a corresponding point on a line that would represent the ground. They're parallel, all right? And your hand is 4 feet off of the ground. So that means the distance from the ground up to your hand is 4 feet. We're going to show all of this information in our diagram. Then it says use your left hand. Oh, okay. Now, because I got to do the diagram thing, right? You use your left hand to point to the top of the house. So let's say the house is over there, right? I got my right hand like this, and then I take my other hand and I go like this, and I'm pointing to the top of the house, right? Say the house is over there somewhere, right? We're using our imagination too, right? So now the angle between your two hands, your right hand and your left hand, if we do that, if we simulate that, is 57 degrees, right? It says that right there. The angle between your two hands, your right hand and your left hand, if one hand is parallel with the ground, the other hand is pointing to the top of a house. So the space in between, right, the two hands, I can't really do it because, I'm one person and I'm using my hands to try to show this, but the picture is going to show it. It's 57 degrees. So that's very important information, right? There's 57 degrees right here. All right. So now the main question is, how high is your house? So how tall is the house, right? If I'm standing here, I put my hand out like this, it's 4 feet off of the ground, right? And I take my other hand and I point to the top of the house, and my two hands form a 57-degree angle with each other, right? Question is, how high is the house? We can use trigonometry to figure that out. We can use trigonometric ratios to figure that out. We might use tangent, we might use sine, we might use cosine, but we're going to see what we use once we draw our diagram. So imagine this. I'm going to say that's me right there. Well, no, that's the ground that I'm standing on. That's me. Boom, boom. Stick man, whatever, right? Yeah, okay. Little stick man drawing. That's me, all right? Then it says I'm standing 20 feet away from a house. Let's say I draw this little box right here. This represents a house. Boom. Maybe throw a little window up in this drawing like that. Got the front door. Boom. Second, first floor. I don't know what I'm doing. Maybe it's a 3-story house. I don't know. Anyway, this is the house. This is the house. This is you. It says 20 feet away. So, boom. Check that out. So I'm taking the information from the problem and I'm drawing a diagram, right? That's me. That's the house. 20 feet in between. All right. Now, extend your right hand straight out. Now, imagine it's my right hand right here. My right hand is extended straight out, parallel with the ground. So that means that, and the length from here to here is going to be 4 feet. So that's 4 feet from the ground. 4 feet from the where the hand is to the ground. That's 4 feet, right? Also, your left hand, you point to the top of the house. Now imagine, I'm not going to show my hand actually pointing to the top of the house, but imagine that I am pointing to the top of the house, which is right here. And imagine that could be represented as a line that looks like this. A line that looks like this. Imagine I was pointing to the top of the house. Here's my one hand that is basically pointing straight at the house, horizontal, parallel with the ground, and the other hand is pointing to the top of the house. That's what I should have said before, right? So it forms an angle that's 57 degrees. So I write 57 degrees right there. All right. Now, the question is, how high is the house? So I want to know what the length is from the ground to the top of the house. And I already know that from here to here is 4. From here to here is 4. Now, what I need to figure out is what's the length from here to here. And then once I know the length from here to here, all I got to do to find out how high the house is just add 4 to that. Add this 4 to that. And I'll have the total height of the house. Now, how do I figure this out? All right. Now, what type of triangle is this? I should first ask myself that question. I know this is a right triangle. And I also know that this is a right angle. I know this is a right angle. And how do I know it's a right angle? Because remember, it said that your right hand was parallel to the ground. So that means that this line is parallel to the ground, so it's horizontal. And we assume that the house is straight up in the air, right? We assume that it's not the Leaning Tower of Pisa, leaning over like that. The house is built straight up in the air. So the side wall of the house is vertical. So whenever a vertical line crosses a horizontal line, they form a right angle or a 90-degree angle. So that's why we draw this little box right here. So now we got our triangle. So now we're about to use our trigonometry. We got to pick a trig ratio. Now, before I said we're either going to use sine, cosine, or tangent. Now, how do you know which one you're going to use? You know which one you're going to use based on what information you have. I know this angle is 57 degrees. And then I say, okay, compared to this angle, I have a length of this side of a triangle, which is my adjacent side of 20. I know that. This is the side I'm looking for, which I don't know. This is my opposite side. So you got to think to yourself, which trig ratio uses adjacent and opposite? Adjacent and opposite. It's not sine, it's not cosine, it's tangent. Because tangent equals, the tangent of an angle is equal to the measure of the opposite side divided by the adjacent side. That's the TOA part. If you ever hear somebody say SOHCA TOA, TOA, T-O-A, that's the TOA part. Tangent equals opposite over adjacent. So what I do is, I'm going to write this. You write tangent of the angle, tangent 57, equals the opposite side, which we don't know yet. We're about to figure it out. So that's x, we call that x, divided by the adjacent side, which we know is 20, because we read the problem. You're standing 20 feet away from the house. So that's you, that's the house. The length in between is 20. So we got tangent 57 equals x over 20. Now you got an equation set up. Now we're just doing a little bit of algebra. We're using trigonometry, and then we set up an equation, but we still got to use algebra. So tangent 57 equals x over 20. So then you take out your calculator, you make sure it's in degree mode, not radian mode. If you use radian mode, you're going to get the wrong answer. We don't want the wrong answer. Tangent of 57, and I got this written down already, because I don't have these amounts memorized. I use a calculator myself. So tangent 57 is 1.5399. And we round this out. We typically use, we round trig ratios out to 4 decimal places, right? So 1.5399 is equal to x over 20. And then I'm going to solve for x by basically cross multiplying, just doing 1.5399 times 20. So I do 1.5399 times 20 equals x. And when I solve for x, I'm going to know the length of this side of the triangle right here. So this is my x. I say x equals the question mark, right? All right. So I do that. I multiply that out. And I did it a little earlier. I got 30.8. Right? But that's not the final answer, because remember, the question is, how high is the house? Remember about this 4 feet, right? This 30.8 is only the measure from the line that's extended from his right hand, right? Or from your right hand that is parallel with the ground. So that means that from here to here is 30.8 feet. So in order to find how high the house is, you got to add in that extra 4 feet. So you do 30.8 feet plus 4 feet, which equals 34.8 feet. And that, my friends, is how high the house is off of the ground. 34.8 feet. You might say 35 feet if you want to just round, 35 feet if you want to give an approximate, measurement. But yeah, 35 feet. So when we're encountered with a trigonometric word problem, you first want to read the problem and try to understand what information you're being given. Then what you want to do is you want to draw a picture. You want to draw a picture, right? Draw a picture so that way, once you draw a picture, that way you can see what you're working with, right? When you can visualize and see what you're working with, it's not as much for you to think about because you're looking right at it on your paper, right? And then you see your triangle, right? You see shapes from geometry or from trigonometry that we can use, that we have formulas and theories that we can use and apply to. Like we just figured out, okay, well, if I know I got this angle and I know I'm looking for this side and I know the measure of this side, then I can use tangent because I know that I'm looking for the opposite side, but I know the adjacent side. That's TOA from tangent. Tangent equals opposite over adjacent, or opposite divided by adjacent. And then you set up your equation like we did here, and then you just go ahead and solve. But make sure your final answer makes sense because a lot of people will fall for the okie doke. What they'll do is they say, oh, the answer is 30.8. That's it. I'm done. Nah, it's not 30.8 because remember about this 4 feet right here. You got to add this 4 feet in. Okay, so you do the 30.8 plus the 4, you get 34.8, and you can round that to 35. Now, I hope that you've already subscribed to this channel, right? I mean, why wouldn't you? I have a lot of content on the page similar to this, and we will be adding more content to this page on a regular basis. So go ahead and subscribe. Go ahead and subscribe. Hit the like button. Hopefully you learned something from this video. And again, if something didn't make sense, the beauty of it is on YouTube. Unless they shut YouTube down, it's going to be on here. You can rewind it. You can pause it, you can stop it. If something doesn't make sense, if you forget why I did a certain thing, just run it back. But please subscribe to the channel, like the video, share the video, tell a friend to tell a friend. And as I always say, remember, there's all this math all around you. Peace.